In this lesson, we are going to work with square roots and know if a square root is a rational number or an irrational number. So we need to first start with knowing our perfect squares. And the way we're going to do this is we're going to start with drawing a number line. And on the number line, I would like for you to label it from 0 to 15. So you might want to pause the video until you get the number line drawn like you see it here. And once you have that done, go ahead and resume play. Now, underneath each of these numbers, we are going to write what each number equals when we square it. So I'm going to do this in red. So 0 squared means 0 times 0, so that's 0. 1 squared means 1 times 1, which is 1. 2 squared means 2 times 2, which is 4. 3 squared equals 9. 4 squared is 4 times 4, which is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196, and 15 squared is 225. It is my expectation that you know all of these numbers by heart. So what we have done, the numbers in red, are called perfect squares. So let's define that. So a perfect square is the product of an integer squared. All of the numbers in red right there are perfect squares. Now what we're going to do is we are going to take the square root of each of those red numbers, and the result will be the numbers in black above them. The symbol for square root looks like this. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5, etc. So when we put the square root symbol on each one of these numbers, which are perfect squares, the result is the integer that was squared. So if we consider the square root of 196, we get 14, because 14 times 14 equals 196. So again, 14 is the square root of 196 because 14 squared equals 196. Another example, 7 is the square root of 49 because the square root of 49 is 7 because 7 squared equals 49. The expression that you see here can be read in two different ways. One way is to say the square root of 64, and the other is to say radical 64. We're going to talk about the different parts of this. The first part is the symbol here, which is the radical symbol. So this symbol here is called the radical symbol. And the number underneath the radical symbol is called the radicand. And then there's a third one that you don't see when we talk strictly about square roots. And that is a little tiny number that you might see inside this space here. And sometimes we have little numbers there. That is called the index. When we have a square root, it is understood that the number in here is a 2. So since right now we are only dealing with square roots, you won't see a little number in that space. It's automatically a 2 when there's no number inside that space, so we're talking about square roots here. So now let's talk about the learning target for this video, which is to know if a square root is going to be rational or irrational. And it really comes down to this basic fact. If the radicand is a perfect square, then the square root is going to be rational. Now, in order to know if it's rational or irrational, that means you must know the numbers that are perfect squares. So let's write that down so you have it in your notes. So, since 64 is a perfect square, the square root of 64 is rational. The square root of 64 is 8. When you take the square root of a whole number that's not a perfect square, the result is irrational, which means, again, an irrational number is a number that, in decimal form, does not repeat and does not end. Let's make a list of rational and irrational examples of of square roots. So as we've already said, the square root of 64 is a rational number because 64 is a perfect square. Another example is the square root of 4. 4 is a perfect square, so the square root of 4 is 2, which is rational. The square root of 144 is rational because 144 is a perfect square. And let's do one more. The square root of 49 is rational because 49 is a perfect square. If we move over to the irrational side, the square root of 60 is irrational because 60 is not a perfect square. There is not an integer that you could multiply by itself that will result in the number 60. The square root of 18 is another example of an irrational number. The square root of 55 is a third example of an irrational number. And the square root of 105 is another example of an irrational number. All of the radicands in the irrational number list are not perfect squares. On the rational side, all of the radicands are perfect squares. So when you take the square root of a whole number, you can know if it's rational or irrational by knowing if the radicand is a perfect square or not.